Descartes' rule of signs. Because an nth degree polynomial might have roots that are imaginary numbers, we should note that such an equation can have at most n real roots. Descartes' rule of sign provides even more specific information about the number of real zeros that a polynomial can have. The rule is based on considering variations in signs between consecutive coefficients. For example, let's look at this function. 3x to the 7th minus 2x to the 5th minus x to the 4th plus 7x squared plus x minus 3. All right, what we want to look at is the sign changes. We have a sign change when we go from a positive to a negative or a negative to a positive. That is a sign change. So in using Descartes' rule, we must determine the number of sign changes that the function has. So when I look at this problem, I went from positive 3 to negative 2. That's the first sign change. That is one sign change. Then we go from negative to negative. That's not a sign change. So from negative to positive, that's our second sign change. Then you go from positive to positive, not a sign change, but positive to negative is a negative or another sign change. We have 3 sign changes. All right, that's important to us. So let's continue to read. It says let f of x, and we have our polynomial formula here to be a polynomial with real coefficients. Number 1. The number of positive real zeros of f is either the same as the number of sign changes of f of x, or b, less than the number of sign changes of f of x by a positive even integer. So if we were to determine the number of positive real zeros of this problem, since we had 3 sign changes, the number of positive real zeros is either 3, because we had 3 sign changes, or, notice our number 1 rule, is the same as the number of sign changes, which was 3, or less than the number of sign changes by a positive even integer. Well, your least positive even integer would be 2. So what we want to do is you subtract the number of sign changes, 3, minus 2. So 3 minus 2 says we could have 1 positive real zero. So according to Descartes' rule, we could either have 3 zeros or 3 minus 2 is 1 zero. For instance, let me also say that you had 7 sign changes. Now this is just an example. Say we had an example of a polynomial that had 7 sign changes. Well, our number of positive real zeros would be 7, or what's 7 minus 2? 5. What's 5 minus 2? 3. What's 3 minus 2? 1. And you never can go below 0. You can have 0, but you cannot have a negative number of zeros. So you always subtract down as far as you can till you get close as possible to 0, but not below 0. So how many sign changes do we have? We had 7. So if a polynomial had 7 sign changes, the number of positive real zeros would either be 7 or 5 or 3 or 2. So we had 6 sign changes. The number of positive real zeros would be 6, or 6 minus 2 is 4, or 4 minus 2 is 2, or 2 minus 2 is 0. That would be my answer of the number of positive real zeros if we had 6 sign changes. Okay? So, in determining the possible or the number of positive real zeros, you look at the original f of x and you determine the number of sign changes. Now, let's go to number 2. How do we determine the number of negative real zeros? It's the same as the number of sign changes of f of negative x. So we must take in the original problem and plug in negative x in for every x. So we will then determine the number of sign changes after we substitute in negative x. And then it says, or less the number of sign changes of f of negative x by a positive even integer. So again, we'll plug in negative x, we will simplify, then we will determine the number of sign changes, and however many sign changes we have, it will be either that number or that number decreased by 2. So if f of negative x only has one variation in sign, then f has exactly one negative real zero. Okay? So we will replace x with negative x to determine our number of negative zeros. Okay? So let's begin looking at, I want us to look at just a few examples of this using Descartes' rule. All right, looking at this problem. We're to determine the number of sign changes. So how many sign changes does this problem have? Well, we go from positive to negative, that's one sign change. Negative to negative is not a sign change. Negative to positive is my second sign change. Positive to positive, no sign change, and positive to negative, that is a sign change. So we have 3 sign changes. So what would be the number of positive real zeros? It would either be 3 or 3 minus 2 gives me 1. Looking at the next problem here. How many sign changes do we have? Positive to positive, no sign change. Positive to negative, 1 sign change. Negative to positive, 2 sign changes. And positive to positive, no sign change. So we have 2 sign changes. So the number of positive real zeros would be 2 or 0. You have to subtract off 2. That's based on the rule. All right, and look at the last one. How many sign changes do we have? From negative to negative, no sign change. Negative to positive, 1 sign change. Positive to positive, no sign change. So the number of sign changes is 1, so the number of positive real zeros would be 1. We don't subtract 2 if we get a number less than 0. So let's look at the last example here that I want us to look at. Using Descartes' rules of signs, determine the possible number of positive and negative real zeros. So to determine the number of positive real zeros, you look at the sign change of f of x. So how many sign changes do we have? Positive to positive, no sign change. Positive to positive, no sign change. Positive to positive, no sign change. So we have 0 positive real zeros. Now, how do we determine the number of negative real zeros? Well, I spoke of that earlier when we were reading our rule. What we will do is we will find f of negative x. We will replace every x in the original problem with negative x. So here we go. Let's replace positive x with negative x cubed, plus 2 times negative x squared, plus 5 times negative x, plus 4. All right, negative x cubed. Well, a negative times a negative gives me negative x cubed. Squaring the exponent first, I have negative x times negative x would be positive x squared, times 2 would give you positive x squared. 5 times negative x is negative 5x plus 4. So now I have f of negative x. So to determine the number of negative real zeros, you replace every x in the original problem with negative x, then raise the numbers inside the parentheses to the power. Now we look at sign changes of f of negative x. Looking at sign changes, negative to positive, 1 sign change. Positive to negative, 2 sign changes. And negative to positive, 3 sign changes. So how many negative real zeros do we have? We had 3 sign changes, or what's 3 minus 2? 1. So we'll either have 3 or 1. So if we were trying to find real zeros in this problem, I would definitely test my negatives because I have a better chance of getting a negative because I've been told by Descartes' rule that I would have 0 positive. So that's where this Descartes' rule really helps us out when we're trying to find real zeros.